Okay, so for today, our first thing is I want to practice this kind with you that was on that little quiz. I'm going to make a little XY chart, and just to keep your life simple, I'm only going to give you 3 points on the XY chart. So let's say we have 2, 1, and 0 here, and we have 3, -1, and 5 there. Do you get, by giving you this chart, I just gave you 3 points. Now, unless it says to graph them, you don't have to. But some kids like to, because they understand it better by graphing it and making it like a picture and connecting the dots. But you don't have to do that. It's just a thing you could do if you want. Next, let's say I give you these directions. I want you to take f of x, and I want you to do this to it. F of negative x plus 6. Then, can you figure out what the new points would be for this one? And I told you some stuff to do to x. I told you some stuff to do to y. Find me the new points for this. I'll pause for a second while you give that a shot. All right, let's see if you're doing it right. On all the x's, what are we doing to mess with the x's? We're throwing a negative in there. That means multiplied by -1. If we were talking about which direction it would go, that would be a horizontal thing. But if we're just multiplying by -1, that's all there is to it. You times everything by -1. So you got -2, -1, and what's 0 times anything? 0. Raise your hand if you had your x's right. Good. Should have been confident then. All right, now how about this plus 6 at the end? Is that a y thing or an x thing? It's a y thing. Stuff on the outside is the y stuff. That's adding 6. Do you trust it? Yes, because it's not on the inside. So you just add 6. So then this is 9 and 5 and 11. Raise your hand if you had those right. Okay, good. Now I'm going to step it up a notch because that would have been a really easy one. What if I throw 2 things on the outside and 2 things on the inside? See if you can handle this. Negative f, oops, don't need that parenthesis. That is clearly on the outside, right? Because there's nothing holding in. Negative f of negative x. I'm going to put it in parentheses and say plus 1 and see if you know what order to do it in. Plus 3 on the outside. There's 2 things to do to each x, and there's 2 things to do to each y. And be careful on the inside. That's the x stuff. Almost everybody will mess up the x stuff. I shouldn't say almost everybody. A lot of you are going to mess up the x stuff. Does the order matter? Oh, yes, it does. Be really careful what order you do your inside stuff in. I'll pause while you give that a try. Okay, I'm not even asking you if you're confident on this one because I get it's tricky on the inside there. Okay, but at least, did you know that it involved the inside stuff involved the x, and one of the things was you were going to multiply by a negative, and one of the things was you were going to not add 1, you were going to subtract 1. Do you get that? Because it's opposite world in there. Okay, now which one should be first? Normally aren't parentheses first, but it's on the inside. So it's not normal. You should have multiplied everything by -1 first, which makes all my x's become negative, and wait a minute, -0 is just 0. So that negative doesn't affect it. Then I'm supposed to add 1, except you don't add 1, you subtract 1. So -1, -1, and -1, and that makes -2, -1 makes -3, -1 -1 makes -2, and 0 minus 1 makes -1. The x's were the tough part. Now, on the outside. That negative is telling me to flip it. But what does that look like number-wise? Make it the opposite of, or multiply by -1. So I'm going to multiply all my y's by -1 times -1 times -1 times -1. And then I'm going to add 3 to them. Plus 3, plus 3, and plus 3. Does it matter what order? Yes, totally. So you got to do the multiplies first because you're on the outside and you follow the rules, which is multiply by -1 happens before add 3. Okay, so I'm going to multiply everything by -1. That's -3, and then I add 3 makes 0. +1, then I add 3 makes 4. And -5, and then I add 3 makes -2. Did anybody get all of those right? Awesome. If you didn't, we still have time. There's plenty of chances to practice this between now and the Friday's test. All right. So there, that's a typical one where they've given you directions and a chart, and you got to find the new points. Some of you are so visual that it would have been way better for you to just graph the original points and then move them the way it said. Do you get what I mean? I could have graphed the dots and then moved them and flipped them and all that. If you're better at that, you can do it that way. But you're going to have to make your own little graph to do it. All right. You don't have to do it my way as long as you get it right and you can show me your work. All right, I want to find this slide in your new stuff. Everybody find this in the new assignment for today. You should have looked under Schoology, under today's date, which is October 2, and you'd found this graph. This one is a normal quadratic. It's a parabola when you graph it. That's what it kind of looks like. These are screenshots from a really good graphing program called Desmos. It's really nice. If you haven't already downloaded that app onto your iPad, I strongly recommend it. The only problem with it at all is that you're not allowed to use it on the ACT tests, so you don't want to get too tied to it. You got to know how to use your regular calculator too, because your regular TI-84 type calculator works on the ACT, but they won't let you bring your iPad in on the ACT. So, all right. So if you were to graph this on Desmos, take a look at how it looks different. They threw a 2 on there in the front. On the outside, notice, there's no parentheses holding this 2 in. So that's on the outside. That means it affected its y. And so that means the y's are all twice as big. Let me show it to you. Do you get, at this graph, we had the point -2, 4, because when you take -2 and you square it, you get 4. Whereas on this graph, we have -2, 8. If you look at the y-axis there, that's an 8, in case you can't read it. What happened? -2, 4 turned into -2, 8. Did the -2 change? No, only the y. What happened to the y's? They got doubled. When you double the y, it gets twice as tall. Now, when you're looking at a parabola, though, it doesn't seem taller to me. It seems narrower to me. So a way to think of it is, imagine you could grab this thing and it was made out of rubber. And you grabbed it here and here with your hands. Those are supposed to be hands. And you grabbed it and you pulled it upwards. You pulled up like this. Do you get, when it's stretched, it would kind of look like this guy? It got vertically stretched. That's how we describe it, as a vertical stretch. Take a wild guess what happens when you multiply by 3. Stretches by 3. It's 3 times the y's. Notice the x's aren't any different. And how about this? Well, it's just 4 times vertical stretch. All right, if we look at the next page here, that is not 3 times taller. It's 1/2 times taller, which means it didn't go taller, it actually got shorter. So instead of a vertical stretch, that's called a vertical what? Shrink. That's called a shrink. And now, again, with a parabola, it looks kind of weird. It looks like it's melting a little bit. You know, it's like sinking down. But if you really look at the point action, it's negative 2 comma 4 changing into negative 2 comma 1. And why? It's supposed to be half as, oh, it's not 1, that's a 2. Sorry, that's a 2. I just assumed it was a 1, but they count by 2 on that axis. So do you get that negative 2 comma 4, the only difference is the 4 and the 2, and it got half as tall? All right, so here's the theme that you need to understand. When you see this, you got to be able to say two things. Number one, is that on the inside or the outside? It's outside. By now, look up at the board, please. I'm changing. Some of you aren't looking up here. This is not in your slides, okay? That's why I want you to look up. This is a vertical on the outside, so that's a vertical what? Stretch. What if I made it 1/3? Then it's a vertical shrink. All right. Now what if I put it inside? Horizontal, and you would think it's a shrink, so it's actually a stretch. That makes it horizontally wider than it used to be. And if I put a 5 in there, it seems like it'd be 5 times wider, but it's actually 1/5 as wide. It gets narrower. Remember, everything on the inside, it isn't that complicated. Figure out what you think it should do, and then do the opposite. Thinks like it's 5 times wider, because this is horizontal on the inside. So 5 times, nope, not 5 times wider. 1/5 as wide. So if I had that little list of points, you know, like XY chart thingy, let's say I had the point 2 comma 10 on here. What part's going to change, my X or my Y, by throwing that 5 in there? That's going to change my X. And it's going to multiply it by 5? No. It's going to multiply it by 1/5. Or you could say divide by 5. That actually would work. All right. So here's a function. You tell me what it would look like. First of all, simplest of them all, square root of x. It's just a little ramp thing. Make a little sketch for me. Sketch me what, just a sketch. The sketches don't have to have labeled points. Just kind of get a quick sketch of y equals square root of x. Like that, right? Raise your hand if you had that. Good. Now, what if I throw a 3 out here? Sketch what you think it should look like. And I hope you didn't move the whole graph up 3, because that would have been like plus 3. That's different. What should you do with a 3 in front? It's like you grab it with your hand. It's my hand grabbing it. And drag it up and make it 3 times more vertical. I think I'm going to call that taller. Now again, it's not just going to move up 3. That's different. It's got to be 3 times as big. So what's 0, 0 change to if I make it 3 times as big? Still 0, 0. I'm not dragging it up. I'm timesing it by 3. I'm timesing the y by 3. So my new graph, if you did this right, should have looked something like that. Raise your hand if you had that one right. Okay, good. It's questionable whether I actually made that 3 times as tall. Maybe I should have made it even steeper. Like that. Because this spot, however tall that is, it should be 3 times that tall up to there. All right, how about this? Y equals square root of x, but I'm going to throw a 4 in there. Would you sketch for me what that should look like? This one's weird. There's your square root. Now what? seems like it should make it 4 times as wide. So it's not that. What is it? 1/4 as wide. So you got to think this way and go, okay, it was that far over. Now it's less far over. It was this far over. Now it's 1/4 of that. It was this far over. Now it's 1/4 of that. This one's weird because it looks like you did something else to it. I'm going to stick to these choices. It looks like I stretched it up, but I actually squished it this way. The graph's been moved over that way. It might look better if it was a parabola. So here's a parabola kind like that. Y equals x squared. Just catch y equals x squared. That should be a no-brainer for you by now. It's your U shape. Then, what do you think happens if I do, and I put it on the inside, the 2 in there? Seems like it should be twice as wide, so it's not. What is it? Half as wide. You get, it looks a lot like the vertical stretch. It does. And that's because if you take something and you times it by 2 and then you square it, or you square it first and you times it by 2 later, it has a similar effect. It got twice as big, kinda, right? But it's on, if it's on the inside and you times it by 2 and then you square it, it's going to be not quite as big, or it's actually a bigger difference than if you would have squared it first and then times it by 2. But either way, you're timesing it by 2. You get what I'm saying? So anyway, that's why those two look alike. It looks kind of like a vertical stretch. Because if you take your parabola and you times it by 2 on the outside, it gets bigger. Or you put it on the inside, it also gets bigger. Either way, the y got bigger. So I know that can be a confusing one. But here's the way I want you to think of it. Horizontal on inside, so that's a horizontal, and then it's the opposite of a stretch by 2. It's a horizontal shrink, so you got to think of it this way. That got narrower. That got narrower. Okay? That's the beginning of stretches and shrinks. And if that felt a little bit confusing, it's okay, because we got tomorrow to like lock it down and make sure you totally get that. And then on Wednesday, we can move into reviewing for the test, which is covering like everything from the beginning. Okay? Now, for some of you, this is totally like, some of you don't need to study for the top 20 anymore. You're totally ready. Others of you, you probably only know 7 of the 20 things. You've got a lot of work to do by Thursday. Okay, it all depends on the kid though. So you really should think about that for yourself. What's the last score you got legitimately on the top 20? And if you've got like a 9, then you should be thinking, ooh, there's probably at least 5 or 6 things you didn't know. Maybe there some of them were just dumb mistakes, but there's probably 5 or 6 you don't know. Better go watch the videos and stuff. Or you could come in the morning. This Wednesday, it'll be a popular day for me, for my mask, so I'll probably have a lot of people here, but you can come. This Thursday is another morning you can get my help. This Thursday is going to be also super popular. Like, there'll be a lot of kids in here. So don't just figure, oh, I'm going to come in on Thursday and he'll fix all my problems. I'll answer a few, but you're going to have a line of people at my desk that's probably 7 people long at least. So I'll answer their question quick, and they'll have to go to the back of the line if they want another one answered. You know what I mean? And I'll just keep rotating through, and I'll help you. But there's going to be 7 or 8 people here on Thursday at least. So if you're struggling with this stuff, take the time between now and your test on Friday, like at home, to rewatch the videos and things like that. Do whatever you can to learn this stuff by Friday. don't just figure you can come in the morning and fix all your troubles. I can help you with a few things. All right. But if you know you're kind of getting in deep here, then maybe you should see me after school any day this week, or Wednesday during Mass, and Thursday morning. I mean, those are all options, but I'm just giving you lots of options. And maybe it's not time to freak out yet because we still have quite a few days to learn this before Friday's test and Thursday's top 20. Yes?
For the top 20 Thursday, will we have 20 minutes?
You will have 20 minutes on Thursday in class. Do you think Thursday is a shortened day or something, or what? Why do you ask?
Say, like, the problem I have is
Time? Gotcha. All right. I get that time is an issue on those tests. Now, there are kids that have special individual plans for that school-wide where you get extra time. If you do get extra time, you get extra time. But if you don't have one of those plans, then, yeah, we got to get you done in 20 minutes because that's the way the ACT is. It's a timed test. And if you got to get used to that idea of being timed because that's the way it'll be. And almost all the major multiple choice tests are timed. You don't have unlimited time. Even on your driver's test, you think the dude administering the driver's test is going to say, sure, stay here till 8 o'clock. I don't care. You know what I mean? He's going to be timed. So, and I do get that puts extra pressure on you, but that's what the ACT does. Better practice it now so you get better at those things. And remember, unlimited retakes. So you can take this sucker, and some kids have like 14 times until they finally got it totally down and got a straight A. And I'm fine with that. Okay, that was a good question. I think we should actually look at some of your homework together so we can do the first couple problems of the homework together. So everybody find the homework, and I'm going to pause while we get there. Okay, so it starts like this. I am going to let you skip the very last question on the page, but there's a pretty small number of problems here today, so I can't afford to have you skip too much more or you'll be missing concepts. And if you need that last one, maybe you shouldn't skip it, but it's optional. The very last question on the page, which is way down here, this funky looking shape right here. You can skip that. Okay, now moving up to here, let's see if you can describe the transformation. I like the words taller for the outside, or shorter. And on the inside, I like narrower and wider. But here's the official way to say it. This is a vertical, what? Stretch. But if you just said that on the test, I would have to mark it wrong. That's why I'm telling you this part. Factor 2. You have to say what the factor is. The stretch factor. Vertical stretch factor 2. That make sense? Next one on the inside. That looks like it's getting smaller, but that means it's actually getting bigger. So horizontal, what? Stretch. And what's the factor? And don't say a half, because a half wouldn't stretch something. 2. Because a 1/2 wouldn't stretch it. The factor is on big number, like numbers bigger than 1, will make it bigger. And if it's a shrink, like the next one is actually a shrink, then your factor has to be a fraction. So like, look at the next one. Look at number 3. Do you get that that's, first of all, is it horizontal or vertical? Horizontal. And it seems like it's a stretch, so it's actually a shrink. So you'd say horizontal shrink, and then factor 1/3 is correct. All right, moving on to this part. Determine if this has had a horizontal or vertical shrink applied. Do you get that is not your normal parabola? If I were you, the first thing I would do is draw in the normal parabola, and it really helps you to tell whether it got stretched horizontally or vertically. Now, I'm going to put it in with points. I just drew it in, and it was pretty bad, so I'm thinking maybe I should put it in with points. 1, 1 is a normal parabola. And -1 goes with 1. 2 goes with 4. 4. Now, just comparing those dots, do you get these dots got moved in? That's what really happened. Get what I'm saying? So was that, did these points get moved up or in? And I say each of these points got moved inwards, which means this was a horizontal shrink. And I know it looks a lot like a vertical stretch, but you got to look where those points went. To do that, I had to graph the original, the parent one in here to see the black ones compared to the purple ones. Same deal here. I graphed the original one on here and try to figure out whether that was a horizontal or a vertical move. Look at the points. Compare them point to point. All right. And do your part. This is not super easy. So you need to do your part, which is to do your homework. I even cut it down to make it reasonably sized. You have to get it done. And there's an answer key. Do you think it's smart to do the whole thing and then check it and find out you were doing the whole thing wrong? Maybe you should check the first couple. Like, make sure you're doing them right before you do it all wrong. All right. Have a great day.